Now I request every participant to be joined as soon as possible, and the meeting is going to start soon. I request our Honorable Principal Sir to come and join the meeting and give his valuable words about the FDP program. With a big round of applause, welcome Dr. GVK Murthy Garu, our Principal, Pace Institute of Technology and Sciences. Sir, over to you.
Good evening to all. Sorry for the interruption due to the technical problem. The session was started somewhat late. Now it is the enough time. Once again, sorry for everyone. Good evening to all. Hearty welcome to the AACT Training and Learning Academy Faculty Development Program on Automation Civil Engineering, conducted by Department of Civil Engineering, Pace Institute of Technology and Sciences. Actually, in this regard, first of all, I would like to express my sincere thanks to AACT for their support for this event. And also, I am very thankful to all the resource persons to accepting our invitation to act as a resource person for this program. And also, I appreciate program coordinator, Dr. G. Ganesh Naidu. He is also head of the civil department. Actually, it is the second faculty development program, Atal, to our institution. Last month, we successfully conducted one Atal ability program in the Department of BEC. Another side, faculty community is the main resource for every higher education institutions. The faculty community drives all higher education institutions. And we have to prepare our curriculum as per the industry needs. All the students are joining in higher education institutions with expectations of learning of advanced technologies. All we know is that technology is changing on day to day. In this regard, all the faculty members are need to upgrade their technical knowledge. All the faculty members are generally attending the workshop, seminars, conferences, etc. to enhance their technical knowledge. Faculty development program is one of the most wonderful program to enhance their technical knowledge to meet the industry needs. Therefore, finally, it is student learning outcomes improvement and also better particularly civil, electrical, and mechanical, these core areas are going to automation in nowadays. Therefore, particularly in civil engineering department, construction industry is almost 10% in India economy. Then, since construction industry is facing a lot of problems nowadays, shortage of workers, skill-related workers, technology, and some quality issues are there. Nowadays, emerging technologies we incorporate in our core areas definitely reduce the technology and also to improve the quality. I hope all the participants to utilize this faculty development program to enhance the technical skills and finally it improves the student learning outcomes. Wish you all the best. Thank you to all.
Thank you for the valuable speech, sir. And we are very happy that we have been blessed with such great personalities around us. And you have been great encouragement to all of us. And now I request, so now let's move forward to the resource person. Now I'm introducing Dr. T. Chandrasekhar, sir. It is very honored to be our esteemed resource person, Dr. T. Chandrasekhar, sir, a distinguished academician and a researcher in civil engineering. He was currently serves as a professor and head of Department of Civil Engineering at Bapatla Engineering College, Autonomous. With an impressive 34 years of teaching experience and 24 years of research, Dr. Rao has made significant contribution to structural engineering, specialization in ferrocement, fiber reinforced concrete, ultra high performance concrete, and geopolymer concrete. He has authored over 126 research publications, many indexed in Scopus and Web of Science, and holds multiple patents in advanced concrete technologies. Beyond academia, he was served as a Board of Studies member, technical advisor, PhD supervisor, mentoring the next generation of engineers. He is also known an award-winning researcher, recognized internationally for his contribution to civil engineering. We are privileged to have him with us today. Please join me in the welcoming Dr. T. Chandrasekharao sir for his valuable presentation. Chandrasekhar sir, this is over to you, sir. Thank you for joining.
Thank you. Thank you, Anandal. Uh, is my voice is audible?
Loud and clear, sir.
Loud and clear. Okay, it's nice. So, first of all, I will share my video. Yes. Again, is there any problem? Yes. Now, is it okay?
Yes, sir. We can see you clearly, sir.
Yes, yes. Is it okay now? Is slides are visible?
Sorry, sir. We cannot see the slides.
Yes, I enter screen. I pressed on this entire screen. Is it okay?
Uh, no, sir. We cannot see any slides.
Is it okay now?
Yes, sir. Yes, sir. Good and clear, sir. We can see the slides. You
Okay,
can
right.
start the presentation, sir. Thank you.
Yes. Because okay, right, first of all, I would like to thank the management of Pace Engineering College and AICT Atal FDP and the HOD of principal of Pace Engineering College, as well as the HOD of Pace Engineering College, Dr. Ganesh, for giving me this opportunity to share my knowledge in this area. So I will go through thoroughly in brief about uh, this topic. So the title of this topic is the predicting concrete strength using artificial neural networks, neural network models, a data driven approach. Is it okay? Is there any problem? Please remind me.
No, sir. It is clear, sir. Very clear.
Yes, yes. So first of all, we'll see what is automation, because the title itself demanding for this automation. Automation is nothing but the technology to perform the tasks which are given the tasks for engineers without human intervention. So why the automation is very much required means the till now the majority of the civil engineering works, particularly in the construction site and other executive works, they completely depends upon human works, but they are prone to majority are prone to error because of lack of efficiency and other being things. So they can be eliminated by using this automation techniques. So now they are emerging field in every engineering area, not only particularly in newly emerged branches are there in most of the engineering colleges. So we have to gear up with that knowledge. So the key features for this is increased efficiency. the automation. Why you are opting this means increased efficiency, reduce human error, and save time and labor costs. How does the automation works with the concrete in strength and crack detection? So by using the sensor deployment, data collection, image processing, and real-time monitoring. So while this automation is particularly you're applying for being a civil engineer, concrete strength evaluation. What is concrete? Everybody knows that. So being a BTech students and every staff member is well versed with this concrete term. The concrete is a composite material consisting of a binding material with the fine aggregate, coarse aggregate, and water or any active material to impart uh, the uh, gel which will bind the coarse aggregate and sand to form an artificial rock that is called concrete. So till now the man-made material concrete, how to know, how will you know the strength of that man-made concrete? So there are different methods are there to assess the strength of that concrete manually. One is compression test, split tensile test, and flexural test, whatnot. There are so many tests. We are also that those tests are included in our laboratory as well as the research works. Without being that, we cannot assess or we cannot report. We cannot report the strength of that concrete. But they are destructive testings. Includes lot of energy, lot of time consumption, and material consumption. All are seems to be at the end of day, it most seems to be more anachronical. So how can you avoid? How can you get the exact the strength of the concrete without doing all these ones? There you will find there you will have that AI and artificial intelligence. You will adopt that one, and we can avoid all these trials and trial and error mixes. So the strength evaluation of ANN application finally will adapt it to the strength prediction and crack detection. You will see in these two ways. One is strength prediction. That means when you are making in a concrete in fresh state, so what proportions you can go directly without much trial and error mixes, trial and errors, so that we can save the material. That is the strength prediction. And the crack, already existing structures, the cracks will appear due to several reasons, whether the existing concrete is in a good condition or it going to be damaged or deteriorate. So these are required the ANN applications. By applying this ANN, you can directly assess the strength of the concrete in existing structures as well as the newly made concrete. Influence the main the strength parameters will depends on the in fresh concrete depends upon the that material composition. So material means the cement, sand, everybody knows that, the fine aggregate, coarse aggregate, and water. In addition to that, the so many parameters, the type of curing and the environmental conditions and the type of mixing, all these will comes into picture. Generally, everybody will talk about the strength of concrete will depends only on the water cement ratio. That is not exactly true parameter. So many parameters will come into the picture where at the end of day to when you are getting the strength of the concrete. In addition to that, the special concretes also they are very much emerging in present days to the lack of depleting the conventional materials. From the last 4 or 5 decades, everybody using the cement products. The concern in that case, so the continuously using this material, finally the next generation we want to find the cement content. So the present generation is already started to replace the conventional materials with the alternative materials. In place that GPC is also comes into picture, geopolymer concrete. No, it is also known as the no cement concrete. In addition to that, the special structures like bridges and cooling towers and high-rise structures, there in place of that normal concrete, you required high-strength concrete. Here I written as the high performance concrete. The only difference between high strength concrete and high performance concrete is high strength concrete, there we will concentrate only the strength parameter. In high performance, we will concentrate strength as well as the durability. In addition to that, for pavement structures where the dynamic loads or impact loads are concerned, then you will require the fiber reinforced concretes. In addition to that, we'll see the the crack formation. The crack formation is a inevitable condition in the concrete, even in fresh state or in a hardened state. Even in fresh state, when the water evaporates due to high temperatures or due to weathering conditions, so immediately the concrete will get. Hello, screen. Okay, right. Uh, uh, uh. Okay, 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 right, right. Okay, I will do that. I will do that. Alag, alag. No, no, no problem. If possible, I try to complete within half an hour. Okay, right. Right, right. I can understand the problem. Okay, right. So we will quickly go through these slides because so I plan to go from the fundamentals, but the cracks. Everybody knows that the types of cracks. One is structural cracks and non-structural. Fundamentally, they are divided like this. Structural cracks. In the structural elements, you will get the due to loading, heavy loading, or improper design. The structural elements like beams, columns, and slab elements usually get this structural cracks, shear cracks, and settlement cracks. Everybody knows that. I'll skip off this one. These are the concerned pictures we can understand structural crack, flexure and shear, and flexure shear cracks. These are the three modes of cracks you have to design for the beams. Only I have taken one example. Non-structural cracks, these are the other type of cracks. So they are not due to loading conditions. They are due to weathering conditions or environmental based conditions. Plastic shrinkage cracks. They are due to evaporation of the water from the surface of the concrete due to high temperatures. Thermal cracks and settlement cracks due to settlements of the foundations. The column will get sinks down, then we will get the superstructure of the all elements will get cracks. This is one more example. In addition to that, the spalling of concrete due to corrosion of the reinforcement in the body of the concrete. So next, what is automation in strength evaluation? The automation will be taking place in different manners. One is non-destructive testing and structural health monitoring, and AI application for mixed proportions and crack detection, and digital image processing for crack analysis. These are the four different modes I have taken for presentation. We'll quickly see this non-destructive testing. So, so non-destructive testing, there are different methods. One is UPV, ultrasonic pulse velocity, rebound hammer, ground penetrating radar, infrared thermography, and acoustic emissions. So this is ultrasonic pulse velocity method. This it will assess the quality of material. Is there any internal voids? It purely depends upon the velocity of the waves passing through the body of the concrete. So if the value of the 4,500 and 4,000, it's in good concrete. It falls below the 3,000, the concrete is not in good condition. So that is the way you can assess the quality of concrete. It's a non-destructive one, and this is the another one, rebound hammer test. This is it will assess the surface strength of the concrete. It's not a reliable one, but immediate results you can partially you can assess the quality of the concrete, but don't rely on this one because you are applying the force on the surface of the concrete. But inner core, what will happen that we don't know. Is there any cracks or something? And another one is the ground penetrating radar. So this is another mode of non-destructive testing. It will assess the internal ones and any pipe leakages are it will be used. And another one is infrared therapy. It is also used particular for detecting the corrosion and layout of the steel reinforcement and its position as well as the present position of the steel reinforcement, whether it is in good condition or is going to be corroded. Similarly, another one, acoustic emission. It is similar to that. So next one is the structural health monitoring systems. So vibration sensors and strain gauges and wireless sensor networks. So type vibration sensor, we are using these sensors attaching to the elements of the concrete structures, particularly for bridges and critical high-rise structures. There, suppose you take the case of a bridges when vehicles are moving on the gutter. So due to this unexpected loads and dynamic loads, the bridges will get vibrations. Due to these continuous vibrations, is there any possibility or is there any case to occur the cracks in that body of the concrete? So the sensors will detect and will give the information, and you can assess the future damage of the particular gutter or as a deck slab of the bridge. So you can avoid that one. Similarly, is similar to that the strain gauges, particularly these strain gauges are we are using in the research areas, particularly in laboratory when a beam is testing for bending or for a shear loading. So what type of strains and deflections are occurring in that particular load, the sensor will give the real data of that test during the testing. And second one is the wireless sensor networks. Here we will use the USB 6363. So this in the different positions, it will collect the data from the dial gauges and a load cell. When beam is testing under a loading frame, the load cell will give the values, and all the values it will be recorded and conveyed to a central point, which is called wireless sensors, and it will connect it to the central processing unit, our laptop. You can convert that analog units into our numerical values. So this is also used for the early crack detection as per as the physical inspections. So this advantage of wireless sensor networks is the efficiency, real-time monitoring, and non-destructive evaluation and predictive maintenance. Coming to the our artificial intelligence, that means what you have means we are finally what I want to say is means artificial intelligence, application of artificial intelligence in the civil engineering area, civil engineering applications. So first of all, you'll see artificial intelligence because it's a complete a branch comes into our civil engineering, similar to our civil and mechanical and electrical, the core branches and the circuit branches. So it is having a lot of demand today. The entire world depends upon the artificial intelligence. So now we'll quickly see what is artificial intelligence. Artificial intelligence is nothing but imparting the intelligence to the computers so that the computers will think like our human beings. We are making our computers to just like our human beings, so that whatever the functions are, whatever the tasks we are executing ourselves, they will give they mimics like our human beings. That is the final output of this artificial intelligence concept. So there are particularly there are 10 branches. One is machine learning and NLP, natural language process. So machine learning, it's in a better, it will become better with the experience. Suppose if a particular staff member is joined freshly into the college, if he allot a subject, he may not perform very good because of his experience. He may be good at the subject, but the conveyance is very, the conveyance or way of teaching will become better and better and experience gains. Similarly, the machine learning will completely depends upon its algorithms. When you given a data and making a model and you are getting something output from that machine learning technology, so initially it will not perform. So repeatedly when you are using that one, after some time it will give better results. That's what it is means. And similar to that natural language process, it's the best example for that is every day we are using this one, chat GPT and chatbot. Without these two, we cannot imagine our life today. So next, coming to this computer vision. So it is this type of AI is used for facial recognition and self-driving cars. So without self-driving cars, this one, and robotics. Robotics, everybody will think that it belongs to the mechanical. No, it's this demand. This technology is implementing in everywhere in the construction industry for demolition purpose. Also, we are using the robotics, and for any heavy lifting heavy loads, we are also using this robotics. And drones is one of the major robotic element in the AI technology. And expert system and construction industry and payment management, you are using this one. So an expert will have a lot of demand initially. So for any important tasks you have to execute this, so the expert member will call. Suppose if you go for any consultancy works for assessing the soundness and the stability of a building, simply a civil engineer is not enough. An expert member in that one. So, in addition to theory, his expertise, experience will count, very much counts. So that what it expert system. And a deep learning. Deep learning is nothing but a one way of machine learning. In machine learning, you will study only the in one way. A deep learning, you will go into the data into very deep, very much deep into the deep learning. So fuzzy logic, it is a one more one. So this is completely a mathematical model. Belongs to it completely depends upon the statistic analysis. How much, how best you are getting, whether the output function is you are getting is exactly or nearer to the our actual output. So whatever the values you are getting and expecting, so whether you are getting nearer to the our expected value or not. So evolutionary computations, structural traffic and GT optimization. Is it okay now? Is
Yes, sir.
my okay, okay, right. Right. So you quickly go through this one. Machine learning. What is machine learning? Machine learning is subset of AI that enables the computer to learn from data to improve over time without being explicitly programmed. It uses mathematical model, analyze and patterns. Okay, right. In machine learning, the completely depends upon the algorithms. And machine learning models are supervised learning and unsupervised, reinforced learning and semi-supervised learning and deep learning. So coming to the supervised learning, these are the fundamentals you required when you're going to applying this AI technology to our civil engineering applications. If there is a raw data, a lot of raw data, a huge amount of raw data. In this, you are particularly interested on some data, some amount of data. You are not bothering about the remaining data. Then you will, whatever the data you are interested, you are label first. Labeling means tag. You are giving the tag to the data, and the data will be transferred to the training program. After training, it will finally you will get what the data you are requiring the output function. They will reflect only the tagged data, labeled data. The remaining it will be filtered. So this is supervised learning. That means initially you are giving the label for the input function. In unsupervised function, you will directly give the raw data, and the machine itself it will be trained for the raw data and it will segregate accordingly. That is called clustering. I will show in the next slide. After that, the machine itself trained by itself, but it will take lot of time and so many iterations will take place. And finally, the output function which will give what we required accordingly. Here is the trained data because supervised learning, and here is the unsupervised learning. And reinforcement learning means it is similar to that an intelligent person, a common person and intelligent person. How the two persons will differ according to their intelligence. If you give any task, a common man will take much of time to execute that work, whereas an intelligent person will will execute that work within no time. That is the advantage of an intelligent person, particularly in police department and military. The intelligent persons will in raw area will use that word intelligent persons and intelligent agents. Similar to that, they will strengthen our algorithms and model by reinforcing some models. That is reinforcement learning. And semi supervised learning is it is a mixed mode of these two, supervised and and the unsupervised learning. That is semi-supervised learning. Here, I already told the clustering. Suppose if raw data is there, much raw data is there. For example, water resource engineering or concrete strength values or something. You take any raw data, but so in clustering, the model itself will be making it to groups. The groups will consist similar properties. The entire data, it will be making into groups. Each group will have the similar properties. This group will not have the similar properties of this one. So this entire group is divided into three properties. This is called clustering. So this technology will be used in the unsupervised learning. That is how the model will segregate this input data. So now coming to the deep learning. Next to that, deep learning. The only difference is deep learning means you are deeply studying the uh, values or the data, including every feature and on something. So deep learning completely depends upon the neural networks, and machine learning completely depends upon the algorithms, and deep learning completely depends upon the neural functions, neural networks. So finally, it is an artificial neural network. There you are using this artificial neural networks for our civil engineering. Artificial neural networks. Artificial neural networks are computational models inspired by the human brain, just like our human brain. You are used to recognize patterns, make predictions, and solve complex problems. The fundamental components of ANN are neurons. Neurons are similar to our brain, basic units that process information from one node to the other node to the another node. There, the entire process will pass through these two nodes. These are the named as nodes or neurons. So the three layer system. One is input layer. This one is the input layer, and another one is the hidden layers. They may be a single layer or two layer, three, and depends upon the data intensity of the data. And finally, what we are expecting is output function. So this is the complete architecture of the ANN. So how the artificial neural network works means data processing through the layers of neurons. Neurons are nodes. Each connection have weightage. That means here you will give some weightage. So I will explain in the next slide. So the modes of activation functions and the learning process, how the ANN will function, how training and testing. These are the two fundamentals. And the types of neural networks are so many neural networks are there. And one of the type is FNN, feed forward neural networks, that we have adapting now. That is the data passing through in one single direction. And another one is multi-layered layers, multi-layered, and another one is the recurring neural networks, and third one is the convolutional neural networks, and fourth one is long short-term memory networks, and generative adversarial neural networks, and autoencoders and transformer neural networks. So the FNN will be used for the regression, and the CNN, this type of neural network will use particularly used for image processing and computer vision, where the images and audios are has to be in detail study is required. Then there you will use the convolutional neural networks. Feed forward neural network will be used for the data analysis, data analytics. For data analysis, for that you are using. But in this also there is a back propagation network is also there. Next slide we will discuss that one. And RNN is for speech recognition. This one is for long and short term are also for the same purpose, generative and similar that one. These are for the different purposes. Almost all they are depends upon the image recognitions. The 1 minute. A application for mixed proportion and crack detection. A stands for artificial intelligence. A and mixed proportion and crack detection use machine learning to optimize concrete mix design for strength and durability, because the concrete completely depends upon the mixed proportioning and the durability. How long the mixed design is task tasking from to get a good strength as well as the durability while detecting and analyzing crash during structural safety. Machine learning and deep learning in strength evolution of the concrete. Finally, why you are using this one is automates mixed designs and predicts its durability. That means the fundamental concept is, suppose if I want to develop a M100 grade concrete, there is no specific codes. Completely how to depend upon the ACA code or Australian code, some foreign codes. For that, I will go with a trial mixes. Take one trial mix, taking the 500 kgs of cement and adding some the 800 kgs of sand and 1200 kgs of coarse aggregate with the water of 160 liters. Water cement ratio I will keep in and around 0.3. There I will catch 3 cubes, test at the end of 28 days. I will get a nearer value of 80 or 90. Okay, then I will realize that so that is not a suitable mix. Then I have to change my trial mix proportions. Then I will go for another trial mix. Alas, after so many trials, I will get at the uh, 20 or 30 trial mixes. Finally, I may achieve or may not achieve. So during this period, I am wasting lot of materials and time and labor. This consumes a lot of energy also. So how can I avoid this one? So anyhow, you are doing the literature survey. Past data is available. What are the different mixes with the different mix proportions are available? So you feed the data as a input data, and whatever the conditions, whatever the local material, and whatever your required own mix proportions, you will ask the and you will feed that as an output function. So it will the ANN model will do all this one, and finally it will suggest. So this mix proportion with this quantities is optimized one, and it is suitable for you. So then you will directly go to that mix proportion and you will test it whether you are getting or not. So that much you can avoid this trial mixes. That is optimized mix proportion and predicts durability. And sometimes it also detects the defects and enhance the structural safety also. So crack detections. This is another way. CNN technology you will use. Here you will use the back propagation. Essential modern infrastructure projects also. So nowadays everybody is depends upon the AI technology. So again, I am mentioned here the ANN models, feed forward neural networks, particularly you are using for the civil engineering purposes. In this, there are so many sub categories are there. One is multi-layered feed forward neural networks. There are so many layers. This is the hidden layer and back propagation. Once the input data is forward to the hidden layers and it will pass through the at the end output layer. Whatever the value you are getting, whether it is more is needed to the our expected value or not. If there is an error, so it will not give it will not display that value. It will again go back to the hidden layers and input function, and here the weights will be adjusted by itself, and again the entire process of calculation will carried out, and finally the output will adjust and it will give the one more another modified value. Finally the value are suitable or not, again it will go back. So many iterations, finally you will get the within a R square value. R square value means quotient of determination. The quotient of determination is in and around 90.9 or 0.95. Then you can satisfy and you can stop your program. That means number of epochs here. You will say in the technical word number of epochs, number of trials you will be passing through the training program. So next one is recurring neural networks. This is speech recognition and for data analysis also they are using. Convolutional neural networks, as per my knowledge, they are particularly using for image recognitions and crack detection. Image recognition means you will take the photograph of an image and you will study in that by image processing technology. And another one is YOLO. You look only. This is also image processing unit, and Resonate and VGG support vector meshes. These are the different models of the ANN. So the next one is digital image processing. If possible, I will cover this one in the. I think I have one more session on 7th. Ganesh?
Yes, sir. You have one more session on 7th, sir.
Sir. On that day, can I cover this one? I will skip off this today.
Yeah, sure, sir.
Okay, right. I will go through this because of the lack of time. I'm running out, so I will go through this one in the next. Okay, this is the slides. Directly, quickly, I will go into this benefits of automation in concrete strength evaluation. So, what is the main advantage? Increased accuracy, no human errors, time and cost efficiency. That's what we have discussed in the previous one. Time, it saves the time. No laboratory experiments, trial and error mixes. Cost efficiency, you are saving the material. You are not going for any trial mixes. Real time monitoring and also non-destructive evaluation, because after trial mixes you have to test it, then only we will know the whether the concrete is getting our required value or not. If it is not coming out, then you have to go for another value. So non-destructive, so the machine itself, it will do all this one, the trial mixes, all this entire process will be carried by the ANN, so that it comes under non-destructive evaluation and predictive maintenance also. So necessity of the study. So importance of automation, traditional methods. Traditional methods means compression testing and split tensile test and flexural testing. Advancements in automation, AI and computer vision and sensors improve the accuracy. And the focus of the study is evaluating the strength and durability. That is our main focus. How will you evaluate the strength of the existing concrete as well as the you are making a new concrete, that, and also you can assess the durability also. So particularly for pre-stressing and high strength concretes and specialized structures. This type of AI technology particularly required for special type of structures. There will use the high strength and high performance concretes and as well as the pre-stressing concretes. So bridge gutters and high-rise buildings and cooling towers. These are the special structures particularly come across with the daily in our life. Our objective of this study is develop automated system, improve non-destructive testing, analyze material performance, and predictive maintenance needs and test reliability. So I will take a quick example for this. This is what I have carried out my research work for one of my scholar. This is already published paper in journal. So I have taken randomly that raw data. So here I have taken one GPC concrete. GPC concrete means everybody knows that everybody is doing are working on this geopolymer concrete. Geopolymer concrete is known as a no cement concrete. Without cement, you are casting the concrete. That's what the present scenario is demanding now. There are so many special concretes are there. So in this, in place of cement, you are using an inert materials, pozzolanic materials. Pozzolanic materials are nothing but a fly ash, which is a byproduct. It's coming from waste product coming from the thermal plants and GGBS, silica fume, metakaolin, like that. So many rice cash, so many materials are waste products are there. So one of the major problem is one of the major problem is the there are a lot of huge quantity of that materials are dumping in the ads. The disposal is main problem, and environmental pollution also there due to, because they are occupying a lot of land area. So keeping all this point in view, so the present research are rigorously using these waste materials as a useful materials. So in that, I have taken fly ash and GGBS, mixing these two in different proportions. But actually, they are inert materials. How can I make this active material? Just like when water is added to the cement, it will become active and it forms a CS gel, that is in a gel having the cementing properties. These cementing properties will group the sand and coarse aggregate. Similar to that, the GGBS and fly ash, basically they are inert materials. I will add an alkaline material. Alkaline material means it is in a combination of sodium silicate and sodium hydroxide with different proportions. And you add this fly ash and they will form again a gel. calcium silicate gel, not calcium silicate, aluminum silicate gel. So this gel is similar to our silicate calcium silicate gel, which is formed in the cement products. So here I tried with varying the GG-based content, 0%, 5%, and 10%, 15%. Here the value is not, it's not clear enough. Here it is 20. The entire blue values up to this 5, these are the experiments I have done in the laboratory. And the corresponding, there is a different methods of curing, not just for just like our cement concrete. Here the curing is a different one compared to the cement concrete. One is ambient curing. Whatever the specimens you are casted by using this geopolymer concrete, they will kept in the open atmosphere. That is called ambient curing. But it's not suitable for winter season and rainy season. Particularly, this ambient curing is suitable for only summer season, where the temperatures are very high. In the presence of high temperatures only, the polymerization will take place, and according to the polymerizations, it will generate the strength. Gels will be formed. If the required strength is falls below that, the gel will not form, and it will not bind any material. So that is ambient curing. But another one is the fast and quick one. Actually, the concept was developed based on this oven curing in Australia. Even kept these concrete specimens in oven and heated up to 60 to 100 degrees by varying different temperature. What is the effect of temperature on the strength of the concrete? 3 hours, 12 hours, 24 hours. Suppose, for example, you take 70 degrees centigrade. I am kept constant for 70 degrees. For example, I am saying. For example, I'm saying 70 degrees. The oven is kept for 70 degrees centigrade, and the one concrete specimen cube is cured for 3 hours. Another cubes are cured for 12 hours. I kept for 12 hours. Next one is 24 hours. So these are time intervals for curing period. Similar to that, the ambient curing is also there. 7 days, 14 days, and 28 days. 28 days means we are hoping that the strength, the concrete will get more than 90% of strength it will achieve. Similarly, the corresponding compressive strength, similar to that, similar to that, the compressive strengths are displayed here. So it is this one is 0% or 5% data is fed into the as input data. It is kept for training, and the remaining data I have given for testing. I taken different hidden layers, and finally output is like this, and the data is generated like this. I didn't done all this one. The inner model, whatever the model I have created, that model has generated this value. So I need not done any experiments on this one. Without doing experiments, the model has whatever the model, back propagation model I have developed, that model has generated this one. So after that, whether the output values are correct or not, then it will give this output functions. Then you can understand the training data versus the target value. So the regression value is 0.89. So the blue line will indicates what it is. It is overfitting. And this one is the underfitting, and this is a good fit. And finally, the output value is 0.89, which is very much less than 0.9. So somehow, because it is in a raw data, temporarily I have given. So this is the how similar to that. There is one more example. Because the lack of time, can I close, Ganesh?
Yes, sir. Thank you, sir. Thank you for the patience and time.
Okay.
Sir, dear participants, if you have any queries, you can raise your hand and ask one by one. Okay, for the time being, we are moving on to the next section.
What is that? What is the data set I have seen in my phone? Large data is required. Temporarily, I have taken small data for example purpose. But when you take a large data, the efficiency will be more and more. Based on that only, in the next example, I increase. It's a 12. All are variables. Water is variable, cement is variable, fine aggregate is variable, coarse aggregate, all are variables. And the next one is also I have taken for 400 concrete specimen data, 400 concrete. So that data, as and when the data is more and more, you will get more data. That means 60 to 70% data will be for the training and 30% data will be for testing. So when the data is more and more, it will give good results. That is the fundamental concept of our ANN. So this another one is the basic concept of crack detection. You can get the from what I call some. You can get the from Google. You can Google it. You can get the data. What next? Otherwise, any experiments you can gather the information. You need not do all this one. Literacy survey itself is a best one to improve our knowledge. I have used my data as well as the another author's data also with his permission to get more and more knowledge. So nothing but it's a training itself is a making more perfect. It completely depends on our searching. Another one is it possible to use 100 data sets? Yes. Why not? So it will requires more and more algorithms. The hidden layers and the neurons will become more and more. So lot of time it will take. When the data increases, the program has to run more time. I think no 100 minimum data means it is only for training purpose only. So large data, I am already specifying when the data is more and more, you will get more good results. There is no any limitation. Suppose if you take a less data, it will give wrong results because suppose if you study less when you are writing the examination, you will get less marks. If you prepared all the 4 units